going back to where we were a second ago, I'm going to put that graph back up. It won't be perfect, it won't be exactly the same, but we'll talk about what the major steps are to make sure you get every single problem you ever get correct. Alright, so to start off, again, I'm going to draw the graph. Okay, so it looks something like this. It had a horizontal tangent, went down to one of these, had a open circle, and then it went, did it go up and back down? I think so. And then, no, I'm pretty sure it had a horizontal tangent somewhere else. But not on yours. Alright. Something like that, right? Alright, so then I asked you guys to make sign charts. So, there we go. And the first sign chart we were going to discuss is if this is f of x, and then I ask you to make the sign chart for f of x, because they're exactly the same function, in your mind you should be looking at y values. And I'm going to look for this. If you're getting your problems right or wrong, I'm going to look that you actually are putting your words, because it helps. Because now that you see that these are y values, do you care that there's a cusp right here? No. It doesn't matter anymore, because you're only looking at y values. So, when are your y values 0? They're going to be at any place that the y value physically is 0. So here, here, here. Okay? And that's it that we have. I think somewhere over here it could have happened again. And then you're looking at undefined there. So that's undefined. This is 0, this is 0, this is 0. The y values during this part of the graph are negative. The y values for this part of the graph here are positive. The y values here are negative. The y values here are positive. The y values all along here are positive. So that's how you get through doing a sign chart using the word. So I just keep saying the word y value, y value, y value. Then, if I take this same exact thing, and I'm just going to rewind a lot. Alright, so I take the same thing, and I say, well, actually, given this graph of f of x, now I want f prime's sign chart. To get from f to f prime, you need to take a slope. So now you say in your mind, when are the slopes 0? Well, the slope would be 0 here. The slope would be 0 somewhere around there. The slope would be 0 here. So I have 1, 2, 3 slopes of 0. See? And then I ask myself, when are my slopes? You're using the word slope. Undefined. Slopes are undefined at cusps. Slopes are undefined at discontinuities. So I put my u and my u. And then you're just going to ask yourself, when are my slopes positive? Slopes are positive when the graph goes up. Slopes are positive when the graph goes up. Graph goes up. Graph goes up. And slopes are negative when the graph comes down, which are these two spots. Okay? So, given a graph, you should be able to find a sign chart. I'll even simplify it more for you. You should be able to do a sign chart using the y values and using the slopes. Because that's what we have, but literally all I have to do is say, oh, never mind, I actually want to call this f prime now. Now that I call this f prime, I still want the f prime sign chart. Is my sign chart actually correct? No, it's completely wrong. Why is it completely wrong? Because I did the sign chart using slopes, but now if you look at it, and let me put my little guy back, from here to here, they're exactly the same function. F prime, F prime. So what does that mean? What's the word that goes here? The y values. Did we do this sign chart before? Yeah, we did a y value sign chart. So as long as you can tell me to get from the picture to the sign chart what you need to do to get there, whether it's y values or slope, it makes the whole problem a lot easier. Because now let's take these things away and just say, can you make me a sign chart for y values? And almost every single one of you can do that. Where you get confused, because you don't write the word and you don't say the word in your head over and over and over again. So when we look at y values, does a cusp matter? No, it does not matter. When I look at y values, do horizontal tangents matter? No, because those are all slopes that matter. Does that make sense, everyone? We good? All right, so that's graphically. So given the graph of f, or given the graph of f prime, you should be able to make an f prime sign chart. That's pretty much one of the major things you're going to start with. second thing, you should be able to use either of these two definitions. F prime of x is equal to the limit as h goes to 0 of f of x plus h. Oopsie, that's not a plus sign. Minus f of x all over h. And you should also be able to use the alternate definition, which would be the limit as x goes to a of f of x minus f of a all over x minus a. Either of those two. Is there one that you guys would prefer practicing over the other? The right side? Okay. So what I would do, so we're going to use the alternate definition, that's the one on the right, and the question I would ask you would be, using the alternate definition, find the equation of, I'll do normal line at x equal to 2 of the function let's do 2 square root of 1 minus x. Actually, on your group test, the alternate definition, which one did you guys do a square root? Did you guys do a fraction? I can't remember. Anyone remember? I want to do a different one is why. From your group test. Let's do a different one. Okay. Let's do 4 over 2 minus x. Let's do that one instead. Practice different ones. Alright, so, walking through the steps, first of all, if I want the equation of the normal line, you need two things. Equation of the normal line, I'm going to need f of 2. Can I find f of 2 easily? Oh, boo. I didn't mean to do that. Wasn't meant to be tricky. Sorry. What did I have? 2 minus x, so let's do 3 minus x. Sorry, I didn't mean to make it undefined. That was totally a mistake. We can't do the equation of the normal line at x equal to 2 at the time because there would be no point there. Alright, sorry about that. So f of 2. F of 2 would then be 4, right? 4 over 3 minus 2, 4. Good. What's the other thing you need? You got your point. What's the other thing? You need your slope. And this is the part that you use the definition for. So we said we were going to use the limit as x goes to a of f of x. I'm just going to rewrite it. Minus f of a all over x minus a. Just throwing things. I'm sorry. Got it? Thank you, Matthew. All right. Go ahead. Try this guy. I'm going to pause. So making sure that you substitute in the correct things. F of x is the physical function that I gave you. So that part, exactly the same. So limit as x goes to a of 4 over 3 minus x. Then minus f of a. It's interesting because it ends up being exactly the same thing. Only difference, there's an a. Okay? And then don't forget your denominator, which is x minus a. Things to not forget. Don't forget to write the word limit. I haven't done a limit, therefore it should still be there. I can't do the limit, because if I put in that x becomes a, I get undefined in the denominator. That tells you, does everyone understand? It means this better cancel. Because if it doesn't, this piece right here, if it doesn't cancel, you can't find the limit. So that's the goal. That is the goal for every single limit as h goes to 0, limit as x goes to a. Your goal is for the denominator to change. Once it changes, then you'll be able to do your limit. So hopefully, most of you figured out that you're multiplying by 3 minus a over 3 minus a. Things that bother me. Number 1, all of that is in parentheses, and so is this piece right here. Because I'm distributing 3 minus a to both 3 minus x. Not just 3, not just minus x, both. And then over here, same thing, 3 minus x over 3 minus x. Sometimes I don't know if the problems were going to work out or not. I guess we'll see. I think it does. Alright, so I get 4 times 3 minus a in the numerator. I get minus 4 times 3 minus x. I'm just cleaning it up so you guys can see it better. The denominator, it really bothers me when you guys don't use your parentheses because it gives you wrong answers later. And then other things that I fix, I don't like putting another denominator. So I'm going to multiply by 1 over x minus a. This pretty much is part of the denominator now. When you do that, you've essentially said now, because everything's multiplied, it's really one big fraction bar now. Everything's being multiplied. All right, so you're just trying to get rid of this guy. Hopefully it works. I think it does. So what do we get as a numerator? We get 12. I guess I'll write it out. 12 minus 4a minus 12 plus 4x all over that crazy looking denominator. Okay. Have I lost anyone? All I did was multiply out this guy, this guy, this guy, this guy, this guy. Do you see them negative? Other thing you guys shouldn't be noticing, you're getting that wrong a lot. Negative 4 times 3, negative 4 times negative 1, which is why there's a positive 4x. The 12s cancel. I'm going to factor out right now. I want an x minus a. So if I do this right, I would factor out the 4, and I would have an x minus a. And that would be 4x minus 4a. Does that make sense to everyone? Now, the piece that I wanted to cancel can cancel. So let's write it a little bit neater, just so you can see it, so that I can see it. I have in the numerator just 4. In the denominator, I now have 3 minus a times 3 minus x. Boop. And now I'm going to physically take the limit, and now I don't have to write the word limit anymore. X goes to a, so make sure you understand the x is the one that changes. This changes now to an a, so you get 4 over 3 minus a, whole thing squared. That was infuriating to see. A lot of you put 2 times 3 minus a. They're multiplied together, it gives you squared. So, what did I find? I found the derivative. Okay? That's all I did. I found the derivative. That wasn't the question, though. It said, find the equation of the normal line at x equal to 2. So what I'm going to do, I hate doing it, but I'm going to give myself a little bit of space to finish up the problem. Put my 4 back. So, f of 2, I need f prime of 2. F prime of 2 would be 4 over 3 minus a, whole thing squared, and then all you have to do is substitute in. This is the piece a lot of groups were missing. If I ask you for the normal line at x equal to 2, then I want the physical slope at x equal to 2, not the equation. So I get f prime of 2 is equal to 4 over 3 minus 2 squared. So really I just get back 4, huh? So y minus the y of the point, that's this guy, equals the slope. Well, the slope, I'm doing a normal. So I don't put, see, the slope of 4. What do I write instead? Opposite, reciprocal. So opposite, reciprocal times x minus the x of the point. That's this guy here, 2. And you get to leave it. You get to leave it in that ugly form. Point slope form. So summary. Find the equation of the normal line. Someone want to give me one thing I need? Just one. Yell it out. The y value of the point. I need that. What else do I need? The slope. To find the normal equation of a line, you need a y value and you need a slope. To find the tangent equation of a line, you need a y value and a slope. Problem's no different. What's the difference? It's this slope. Okay, that's the only difference. All right? If I asked you for this exact same question, equation. I give you this equation, I say to you, prove if there are any horizontal tangents. You saw that in Chapter 2 test. That would be valid for 3.1 to 3.2. If I asked you, prove if there are any horizontal tangents. Does everyone agree that this side of the board, all this work is still valid? All that work you did, you still need it. Because what's a horizontal tangent? It's when your slopes, which is down here, your slopes are equal to what number? Equal to 0. So you really are just creating that equation and solving. Okay? Normal line, tangent line, horizontal tangents. What if I say, I want to know where the derivative equals 4? Where the derivative equals 4. So I do all of this, and then what do? Set equal to 4 and solve. Okay? So you can answer more questions than what I've given you in class based off of the fact that you can find the derivative. I can find the derivative to use it to find the equation of a line. I can use the derivative to find the equation of the normal line. I can use the derivative to find me slope values. Okay? Those are all the things you should be able to do with it. All right, next. One-sided derivative. So f of x is equal to the equation of so my first question would be find all the places where I guess the only question I should say. My question would be, where is f of x not differentiable? Okay, this will be a quick, easy one, and then I'll do a little bit longer one. All right, where is f of x not differentiable? And what most of you will forget to do, you'll forget to check the pieces. Where is the top piece not differentiable? What happens at x equal to 0? It's undefined, right? But this says we only use it for x greater than 2. So will x equal to 0 matter? No. So you get to cross that off the list. Did you need to check it? Yes. Because all I needed to do was switch this to less than 2 and switch this to greater than 2. And all of a sudden, that's part of your answer. So don't forget about the pieces, okay? So then the second thing is, well, this guy, no problem with this. We know it's differentiable everywhere because it's a nice polynomial function. So what's the only other place we got to check? Because this is the one discontinuity on that first part. The second one has no discontinuities. What is the only other place we need to check? X equal to where? 2. What do you check first? Before you do differentiability, you always check continuity. All right, so continuity here. What do we get? Continuity. We get -1/2 for my left side. I'll do this. I'll just write it in notation. 2 from the left. That wasn't the left, was it? I think that was the right, wasn't it? That's the right side. What about the limit as x goes to 2 from the left side? The left side is this one here. And the left side gives us 0. So what do I know? What do I know that those are not the same? What is the end statement? At x equal to 2, the function is not continuous, which then means it's not differentiable. So now, how many places on this function that I gave you is it not differentiable? How many? Total of 1. The x equal to 0 doesn't matter because it's not within that domain. Okay? So let's do one where you actually have to do the work, the process. So f of x is equal. I'm going to actually not change the function just so it makes it a little easier. So that was -1/2. Whew. All right. So x. Let's try to make it not, leave the function alone, but I'm going to change the number so it makes it a little easier for us. That way we don't have a fraction. All right, so I need 1, so 2 minus x squared. I need -1. -1. Let's do -x squared. There we go. All right. Oh, wow. That happened? That really did just happen. All right. There we go. All right. Where's the function not differentiable? Okay. So first of all, do we care about x equal to 0? No. So x equal to 0 we don't care about because it's not within the greater than 1. All right. This guy, -x squared. Are there any places on -x squared that does not have a derivative? What should you be thinking in your head? What are the places you're thinking about? Discontinuities. What else are you thinking about? Cusp, corner, vertical tangent. That list of things is what you think about when you ask yourself, is it differentiable? It doesn't have any of those, so we know we're good. All right, so continuity. Obviously, I tried to make this problem work out. So continuity, left side. 1 from the left, that would be the bottom function, would be negative 1. The limit as x goes to 1 from the right would be negative 1. And then between the two, you have to find f of 1. You're using this function right here, and that gives you negative 1. So yes, we're continuous because all three are the same. All three have to be the same. If these are the same and this one isn't, it's not continuous. All right, so that's done. Now the big pain in the butt part. Differentiable. This is the one you should be able to do. I have a tendency to always use the limit as h goes to 0 from the left at first. So things that are helpful. If I want to know if it's differentiable at 1, then use the 1. If I want to know if it's differentiable at 5, then use the number 5. It makes the math a lot easier for you. And then over here, all over h. Is there anyone that needs me to physically go through the process of those two sides? Okay. I'm not going to take too much time because I have one other thing I want to go through, but I will go through it a bit. Alright, so let me go back and just make sure I remember. So this one's the left side, this one's the right side, and this one's the y value. That's the first thing I do. Left side, right side, y value. I label them. So now I know that if I'm going to use the left side, that I would do the limit as h goes to 0 from the left. Then this better be the left function, which was negative x squared. This one here better be the right function, which was negative 1 over x. F of 1 we already found. What was f of 1? We found that in continuity. It was negative 1. So you have all the pieces you need. Now we put it together. So here I would have negative 1 plus h is my x value squared. Then f of 1 is negative 1. You'll notice I do this with my minus sign just to make sure I don't forget about the negative on the outside. All over h. On this side, we have the limit as x goes to 0 from the right. Here's the function we're using. I'm going to do negative 1 over 1 plus h minus negative 1 all over h. That's what you're simplifying. Things that you guys mess up, you have to square first before the negative. You have a negative on the outside right here, a minus sign. So those are the two major things that I've noticed people mess up. Okay? Matthew, is that enough? It's usually the start that people get wrong. We're good? Okay. All right. Yep, Douglas? I'll be very specific. I will be very specific. Okay? So if I say to prove a non-differentiable point, then yes, you have to do this. If I don't say prove it, and I just say where is the function not differentiable, which is the next thing I was going to do. So I could easily ask you this question. Where is the function not differentiable? And if it's not differentiable, what's happening there? Okay? So what do? We look for the weird things. Just because of that, what do I know is happening? Even over odd? You're guaranteed a cusp. So that's the first thing. Figure out what you have. Now figure out where. Who belongs to that power? X minus 5. So what do? You take x minus 5, set it equal to 0. That'll tell you where it is. So what do I have? At x equal to 5, I have a cusp. So you have to know your powers. Okay, at x equal to 5, I have a cusp. No issues here with differentiability, no issues here with differentiability, so the only place could be at 3. So what do you check first? Continuity, and we get negative 1. Continuity, we get 7. But I will ask you, what is the type of non-differentiable point you have? This is not differentiable. Why? It's not continuous. What kind of not continuous point is it? It's a jump discontinuity at x equal to 3. You have to know all of that. So stuff from chapter 2, still have to know it. Okay? How do I make a vertical tangent? What's an easy vertical tangent to make? Odd over odd. So 5/3. Vertical tangent? Khalid, why not? Say that one more time, hon. Okay. So the power has to be between 0 and 1. So 3/5 works, but 5/3 does not because it's bigger than 1. Okay, so don't get confused with that. Absolute values. Don't automatically think that an absolute value always has a corner. Is that differentiable everywhere? Easy. There's a denominator. You can tell right away where's the one place that you 100% know it can't be differentiable. X equal to 3. Question is what's happening at x equal to 3? Because absolute values, you guys right now always think corner. There's no corner in this graph. It's a jump. At 3, I believe the graph should look like, wait, that way? 1, 10, so it's negative, so it's this way, and this way. And this is at 1, and this is at negative 1. So that has an absolute value, but it is not a corner. So this is not differentiable at x equal to 3 because of a jump discontinuity like before. It's just a different type of jump. Okay? You have to kind of be able to mix those things. The one last thing I want to go through is, let's see if you guys can do this. The limit as h goes to 0 from the left of f of 3 plus h minus f of 3 over h equals positive infinity. The limit as h goes to 0 plus of f of 3 plus h minus f of 3 over h equals negative infinity. What's happening? Whew. And I'll actually add in, I should add in one more statement. The limit as x goes to 3 of f of x equals f of 3. So there's 3 things I just wrote. All right. Top one, what's it say in words? Well, I can read it. What does it actually say? Continuous. It's continuous at x equal to 3. That's all it says. You have to know that. That's why we know our definitions, because I don't actually write the words. It is continuous at x equal to 3. That's what I write. So that's our definition of continuity. Where are they checking it? At 3. So now I know it's continuous. Whose definition is this thing? Well, you're going a little bit ahead of me. Simply stating, very simply stating, we all agree that this is the derivatives definition? Okay, where are they doing the derivative? At what x value? 3. From which side? To the left. Okay, so then this makes it easier to write this one. So let's skip the middle. The derivative from the left side is positive infinity. The derivative from the right side is negative infinity. What's the only way that you can create a continuous point that has a derivative from the left of positive, but a derivative from the right with a negative? Are we guessing or are we telling? Don't raise your hand. Cusp. Any others? Are we sure? Michael? Vertical tangent. All right, any others? Okay, so let's draw them. So whenever you guess one, maybe we don't know which one, draw. I always, you guys see me every time trying to draw a stupid vertical tangent. Okay, and then maybe you think, oh, maybe it's the decreasing one. All right, there they are. So, trying to get to the weird points here. We're going to say vertical tangent, and then there's our cusp. From the left side to right side, well, this is positive infinity, so I drew it the wrong way. There we go. Picture 1, picture 2. Picture 1, picture 2, picture 3, picture 4. Which one works? From the left side, coming in from the left is positive infinity. So, is that positive on the left? Positive slope or negative slope, guys? Negative, because it's sloping down, so that one can't work. From the left side, positive slope or negative? Negative, so that one can't work. So we're back to the same two you guys said. So which one is it? Well, from this side, positive slope or negative slope? Positive. From this side, positive slope or negative slope? Positive. From the right side, positive slope or negative? Positive. Positive or negative? Negative. Which one does it have to be? Cusp. But I gave you all those definitions. If you go back in your notes, you have to know them. But notice the way I wrote it. Did I use any words at all? I don't usually do a study session before this quiz. This would be a test question. All right, this is happening, this is happening, this is happening. What is it? It's using all your definitions. So that means go back and make sure you study your limit definitions of a cusp, a corner, and a vertical tangent. Because, let's make this board slightly neater. This will make it a little easier now that you know what I'm looking for. Now what's happening? There's no infinities anymore. So what's happening? It's still continuous, but the slope from one side is 5 and the slope from the other side is negative 3. Corner. If you know your definitions, it makes them a lot easier to do. Okay? I will tell you the one thing I haven't done on the board, in class, any of it, I could say, just draw me a graph of f of x. That satisfies that. So me telling you this, but then giving you f prime undefined here, what are the possibilities of what's happening right here? The point exists, and then I might say things like f of x must be continuous. That makes it a little harder, but here, value's 5, has to be continuous. What are the things that could possibly happen right here? Corner, and what else? A cusp. Can a vertical tangent happen? It cannot. Can anyone explain why? Ika? Do you know? No? We just saw it happen. Vertical tangent. From the left, positive infinity. From the right, it's still positive infinity. Can you ever have a vertical tangent change signs on your sign chart? No, we can't. So knowing those things, this is the same question that I just asked. I just asked it differently. All the information exactly the same, I'm just asking it completely differently. It's a continuous point with an undefined derivative, but my sign chart goes plus to minus. So these are the two that it could be, can't be a vertical tangent. Okay? Are we good? You could. I could tell you to graph that. I think that would be a fair thing to do. Based off of a sign chart, make a graph. Okay? Alrighty.